Hey everyone, Laz here, Methuselah Mindset. Welcome to another one of our videos in the knowledge-based series. We have got some fascinating new research to share with you today. This was published in nature.com just a few days ago on the 6th of December. As always, I will include links below in the description to this summarized article by Max Kozloff in nature.com, and also the full study and article in its entirety, and a rather lovely little summary which I'll come to at the end of this video from science.org. So let's get into it, guys. You're only as old as you feel, so the adage goes. But new research suggests you may really be as old as your oldest organ. Scientists say they have developed a simple blood test-based method to measure the speed of aging in individual organs such as the heart and brain. When an organ is substantially older than a person's actual age, the risk of death and diseases related to that part of the body shoots up, the researchers reported. One organ in a person's body can age faster than the rest, with implications for health and mortality. As people age, their cells undergo a raft of biochemical changes that lead to organ damage and eventually, unfortunately, death. But a new study that tracks proteins suggests that these changes aren't uniform, and individuals' organs can age at different rates, and a given organ can age at a faster rate in one person than in another with the same chronological age. The authors studied 11 major organs and report that all of them can be subject to accelerated aging as defined by the levels of certain proteins in the blood. Around 1/5 of the more than 5,600 people who participated in the study met the authors' criteria for accelerated aging for at least one organ. Such hyperaged organs are linked to a higher prevalence of disease, and having one organ of unusually advanced age is linked to a higher risk of premature death, the study found. Tests for proteins related to organ age could help researchers to develop treatments for age-related health problems and could also guide personalized treatment plans, says Hamilton O, a computational biologist at Stanford University in California and a study co-author. Physicians already monitor patients' levels of some proteins, and the author's test would be expanding their toolkit, he says. Aging by numbers. Previous research has identified several hallmarks of aging at the cellular level, such as the accumulation of DNA mutations and changes in the epigenome, the collection of chemical tags on a person's DNA. Over the past decade, researchers have developed algorithms that harness these indicators to estimate a person's biological age, which can be higher or lower than their chronological age. Another hallmark of aging is a shift in the proteins that the body produces. To explore how organs age, O and his colleagues first analysed nearly 5,000 proteins in blood samples from 1,398 healthy adults. They identified about 850 proteins that originated mainly from a single organ and trained a machine learning algorithm to predict a person's age on the basis of the levels of these proteins. They validated their model using blood samples from more than 4,000 other people. The results showed that an organ's biological age is linked to disease risk. For example, roughly 2% of participants had accelerated heart aging. That is, their levels of blood proteins relating to heart aging differed substantially from those of other people of the same age. Having a prematurely old heart was linked to a, now get this, 250% increased risk of heart failure, the authors found. Marking time. Some researchers have used epigenetic markers to show that the pace of organ aging varies between individuals, but it's not clear how epigenetic changes are linked to aging, says Matt Kaberlein, a specialist in the biology of aging and chief executive of OptiSpan, a biotechnology company in Seattle, Washington. Proteins are much closer to the downstream mechanisms that might be driving aging, he says. Protein biomarkers might help researchers to identify targets for anti-aging drugs, he adds. Combining various hallmarks of aging could lead to more robust tests of organ age than protein tests alone, says Sarah Haag, an epidemiologist at the Karolinska Institute in Stockholm who specializes in biological aging. She praises the impressive amount of data the researchers analyze, but cautions that it's not clear whether the proteins are driving the aging process or are byproducts of it. It's also unclear whether the team's algorithm predicts disease risk or simply reflects protein changes caused by diseases. Kabeline says that determining casualty is important but time-consuming. In the meantime, with further research, these protein biomarkers might help people by directing them to change their lifestyle or take some supplement, he says. That's powerful, regardless of casualty. Several tests that use biomarkers to assess aging are already on the market, but Kabeline cautions against relying on these. The idea of having a non-invasive way to predict organ health from one sample is exciting, but we don't have a good understanding if these clocks are actionable or precise yet, he adds. Now, again, as I've said previously, guys, please click on the entire study. It is fascinating stuff. It's a big read, but it's well worth it. Let me give you this related article from science.org. As I've said again, the link's below. Gives a rather nice summary because there's some fantastic stuff, but there's more work to come. The team's findings are compelling, says Daniel Belsky, an epidemiologist at Columbia University's Mailman School of Public Health and consultant for multiple companies focused on aging and longevity. They've produced at least initial data suggest that the measurements of organ aging they're generating are potentially informative about disease processes. But he and other researchers caution that much more work is needed before the method could be applied in a clinical setting. Aging is a key driver for some of the world's biggest killers, including diabetes, heart failure, cancer, and Alzheimer's disease. The number of years we've been alive, our chronological age, provides some information about our risk for these diseases. But to improve these predictions, scientists have tried to develop measures of biological age that better reflect our body's wear and tear. These include monitoring chemical changes to DNA over a person's lifetime and tracking the composition of microbes in the gut, the good old gut microbiome. An easy measure of organ aging might let doctors predict who's at risk of what diseases, perhaps in time to prevent them, says Weiss Correa, who is listed as an inventor on a patent application related to the new technique and has co-founded companies that track blood proteins in aging and disease. The approach could also be useful in clinical research, he says, perhaps to measure the effects of drugs or lifestyle changes that aim to reduce aging-related illness. But Daniela Witten, a biostatistician at the University of Washington, questions how much information the organ age signature adds to what a doctor could already deduce about a patient's health from existing blood tests and other assays. She adds it remains to be seen how well the technique works beyond the 5 specific cohorts used in the study. Although the work is interesting and sophisticated, it relies mostly on snapshots of people's health at one or a few points spread over a long time, says Luigi Ferici, scientific director of the National Institute on Aging. Replicating the same patterns and data obtained over short intervals, every couple of years, say, could allow researchers to make more accurate predictions about how and when a person might get sick, and thus make the work more translatable to the clinic. Weiss Correa agrees the approach needs further validation with larger and more diverse cohorts, and says his team plans to run its analysis with data from tens of thousands of people from the UK Biobank. He also wants to replicate the findings in mice and to use the animals to explore in more detail potential links between specific proteins and organ aging. So, fascinating new research, guys. Again, nature.org, links are below, just released the other day, 6th of December. Highly recommend you give it a read. Otherwise, thank you for your time. You know the call. Love, respect one another. Get yourselves outside. Get yourselves moving.